In this series of videos, we're going to look at the forces between molecules. So these are forces that occur between simple molecules. So we're not talking about ionic bonding or metallic bonding or covalent bonding. We're talking about a weak force of attraction between two molecules. We're going to break this down into three separate sections because there are three different types of intermolecular force between molecules. The first of those is going to be van der Waals, and then we'll look at permanent dipole-dipole, and then we'll look at hydrogen bonds. So just as a brief introduction to the three types, we've got van der Waals. These occur between all molecules. So all molecules will have this weak force between them, but it is the only force between non-polar molecules. We need to be very careful with language when we're talking about intermolecular forces. So it's wrong to say something like methane is van der Waals. Methane molecules, plural, have van der Waals forces between them. It's an in-between force molecule. So there isn't van der Waals in methane, the molecule. There's van der Waals between methane molecules. So we need to be very careful with our language. Permanent dipole-dipole forces occur between polar molecules. So in the previous video, we looked at what makes a molecule polar. If a molecule is polar, we will have permanent dipole-dipole forces between the molecules. So one HCl molecule can attract another HCl molecule. And then we have hydrogen bonding between molecules that have N, O, or F bonded to H in the molecule. So if in the molecule there's a hydrogen bonded to an N, an O, or an F, then that molecule will attract another molecule with an N, O, or F in it via hydrogen bonding. And if we were to compare these three, if the molecules are roughly the same size, then as we go down, we could say that this is increasing strength for the same size. So it's not fair to say that hydrogen bonds are always stronger than van der Waals, but if you have two molecules of roughly the same size, then the hydrogen bonds will be stronger than the van der Waals. So let's look at the first one of these in this video, van der Waals forces. So these are the only forces present between non-polar molecules. How do you get a force between molecules that have no uneven distribution of their charge? So a non-polar molecule has even distribution of charge. How do you get then a force between something that has no kind of negative or positive parts to it to another molecule that has no kind of negative or positive parts to it? Well, it's not fair to say that they have no slight unevenness of charge. What they have is that over time, the charge is evenly spread, but actually the charge is moving at all times. So what we would need to be able to say to an examiner is how it occurs. We say van der Waals forces are caused by movement of electrons. Electrons are always moving in the shells, in those energy levels. So movement of electrons in the molecule form a temporary dipole. So just for a fraction of a second, the electrons are not evenly distributed. That gives you a temporary dipole in that molecule. That temporary dipole, so that positive and negative end, then go near to another molecule. In the next molecule, because the electrons in the first molecule are unevenly distributed, it kind of repels the electrons in the next molecule and causes a dipole in the next molecule. And then we would say the delta plus or the delta minus, doesn't matter which you choose to start off with, end of one molecule. So one molecule has a temporary dipole and there is a sort of delta plus end to it. Attracts and then when you say the oppositely charged dipole here, and it must be the delta, it can't be just a plus and a minus. and it's of a neighbouring one, so it can't be the same molecule. So it attracts the delta plus end of one, attracts the delta minus end of another, so in between molecules. Now, the bigger the molecule is, so the bigger the size, the more electrons it will have. The more electrons it has, the stronger the induced dipoles will become, and this results in stronger van der Waals forces between the molecules. We can see this in this set of molecules here. If we look up these in the periodic table and add up their MRs, we get 16, 12 add 4, we get 32.1, we get 76.6. We're just adding up the numbers from the periodic table. We're adding 4 H's, 4 1s onto the AR of the first element. We can see the size is increasing, the MR is getting bigger. If we look at the boiling points, we can see that it is increasing because they are negative numbers, so we're going up the number line. As size increases, so as that MR increases, the number of electrons increases. So there are stronger van der Waals forces between the molecules. So van der Waals are caused by moving electrons that create dipoles that induce dipoles. The delta plus end of one attracts the delta minus end of another molecule. The more electrons, the stronger these van der Waals forces will be. Just think about size is important. Bigger size can mean stronger van der Waals.